this information: motor, motor address, version, serial number, model number, sample period, blah, blah, blah. Down here you see display Animatics database. I'm going to click on that for a minute and show you what it finds. Okay? And I'm going to put it out here in the middle of the screen where we can read it for a moment. There's a lot of data there. A lot of it is hardware related. Okay, it's things that we put in the factory to limit how this motor functions. This is a data block section that you cannot write to. You can only read from it. We ship these things out with certain values in them that allow them to run properly and safely. You'll also see stuff like board production date, IP sealing, of course, encoder resolution, which, by the way, you can read that from anywhere. Hardware options, COM options, and so on. You get down here and you'll find out our default tuning, KP, KI, KD, and so on. Down here you see V-bus high threshold divided by 4. What's 4 times 18? That's 76 volts. This motor is shipped. Is that 76? 4 times 18. Yeah, that's 76. 72 volts. Okay? So the motor will trip offline at that voltage. It will literally say, I got a bus over voltage fault if you exceed that. Okay? You'll never see it otherwise. Heads up to the Ys. We had the wrong value in here last year for a while. So there are some motors out there that if you get unknown trips and don't know why, and your customer's getting ticked off, give us a call. That may be the reason. The value was accidentally put in at 13 for a while, which would have been 56 volts. That was way too low. We didn't find out until later, and then of course we fixed it. So just be aware that that was the case. You'll also see shunt enabled. This is for another product that has a built-in shunt. There's also a low bus voltage threshold. I don't know where it is. Here it is, right here, 8 volts. That's directly in voltage. Okay? If you go below 8 volts, it will also shut down. Okay, why do you think we did that? Why would we have a low bus voltage fault? High bus voltage makes sense. We're going to protect it. What happens when the bus voltage goes down? What does the motor do? What can it not do?
It can't run.
Well, it can't run. It can't run as fast. Okay, let's suppose you have a really slow-moving application. I mean, it's just moving snail-pace slow. You don't need that much voltage to run it. What's wrong with the bus voltage going way down? I'll give you another hint. It's moving slow, but it's a really heavy load. Power is power. If voltage goes down, current goes up. What's going to happen is, if you get bus voltage way down there, PWM is going to increase out to the drive stage to make up for the lack of voltage. As a result, heat goes way up. Current consumption through the MOSFETs goes way up. And next thing you know, you're going to burn out the drive. It may not be going that fast, but in reality, back EMF is what limits peak current through a winding. Some people will say, no, it's the way you run your drive. Well, yeah, we're talking about the motor itself. Okay? If we have 48 volts on a bus, and we have a 1 ohm winding in a motor, and we turn on the switch to say, turn on this phase, well, if it's only 1 ohm and it's 48 volts, it's going to get 48 amps, period. That's the laws of physics. How fast it gets to 48 amps is another question. There's some inductance in there. There may be some other parasitic resistance. But the bottom line is, the slower you're going, the higher the current's going to be in those windings on a continuous range. Because there's no back EMF to suppress it. So we have to put in a low bus voltage threshold to prevent excessive currents. Okay? So that's another limit you may need to be aware of, and that's hardware. We also see, well, maximum temperature. Somewhere in here is maximum temperature, and it's 85 degrees C. Just, I don't know where it is, and I'm not going to search for it like a second. Somewhere in there is a thermal limit. Actually, I don't think it is written in here. I think it's in firmware, and we enable